Hi, I'm Steven. So today I'm going to share my demo of my project called Autohome. So Autohome, that's home automation system. You can interact with your devices. So what I did is doing this through a cloud architecture. So first, let's look at what my Autohome can do. Device type, I have two kinds of device. One is light, one is thermostat. And inside my Autohome, the tasks they can do, first, I can remove or add a light. Second, I can switch a light. Third one, I can set temperature for a thermostat. And four, I can log all the operations I did. So here is the architecture. So basically, I put all the things into the cloud. So you see as here, I'm a user with a client program coded by using Python. So once my user made a decision, there will be a command going through my Autohome string. This is running by Kinesis data stream, and then trigger a lambda function, which I call Autohome function. So this function can recognize my command and split the message. After that, doing the analyze with my message, you can update with two DynamoDB tables. So I deploy two databases here. One is called device database, store the device's status, and one is called the event database, which store the logs. After updating two tables, my Lambda function can also publish this message to my IoT core using an MQTT topic. So if there's any Autohome physical devices subscribed to this topic, it can take these messages and then doing some actions based on what they see these messages. For this implementation, I will just only cover the cloud part and the client part. Since I don't have any real physical devices, but I believe this part will be some extension once I have it, and it will be really easy to just plug in. The pros and cons of my solution, we can take a look at. First is the advantage. So in my architecture, I actually run inside us, we call it serverless architecture. That means there's no server really needed. You can use this kind of method to reduce your cost. Things Lambda function will just run when you need it to run. It's not like a server you have to run probably permanently, even though you got no tasks. So serverless that means no VPC needed, and this also using serverless, that means your deployment will be very fast and highly scalable. So no matter how large your available needed, my solution can always cover it. And also using serverless compare with DynamoDB or Kinesis Stream or MQTT, the latency will be very, very low. So basically, you can enjoy a real-time application here. The disadvantage with my architecture. First thing is it's more challenging on developing since you don't have a server to test. You can only do is put your things into your Lambda function and then test the whole architecture again, trying to find some error here. Also, without a server, that means your Lambda function cannot support a long-term running. And also, the performance is not stable because it's not like when you have an instance, you custom all the things, all the computing power or the networks. Sometimes if the network goes to in some peak hours, you may suffer a little bit on the latency part. So the first thing I need to really specify is a Kinesis string because it's probably the most necessary component here, since my message need to deliver from here to my Lambda function, and my Lambda function need to know what this kind of message really means. So for here, I define my message. So every time my Kinesis string will deliver a string that contains my component ID, status, temperature, and action. Component ID, that's a string describes my device ID, and I also specify with light on thermostat. So if it's a light, start with an L. If it's a thermostat, start with a T. And next one is status. So status only includes 0 or 1 that describe the current status of my light, and this digit will be used only for light. My temperature. So temperature will be a number written in decimal. Describe the current temperature of thermostat, and for here we use degree of Fahrenheit. And also this digit will be only used for thermostat device. And finally, we have action. So action helps our Lambda function to know what it's going to need to do. So here we have a specific string that describes our client action. We have add, remove, on, off, and set. So by these specific strings, my Lambda function can know if there's a message coming in. Then what's my next step? So if I'm my Lambda function, I see this message L800 add, that means I need to add my light, which is called L8. If I see T7175 set, that means I need to set my thermostat T7 to 75 degrees Fahrenheit. So the first thing is to build up my application. So I have put all the things into GitHub. You can just go here. So there are two major components, the AWS template. So it's a JSON file. So you can use this to build the whole system inside the cloud from AWS CloudFormation by create a stack. And then you have a client program. So you can run a script, which is in Python, to test my Autohome system is good or not. Okay, so this is my GitHub. So we can simply download things here. This is my client, and this is my template. And I have introductions and instructions to help you build up your function to your application and test run it. So after you create a stack and build all the components inside AWS, you can take a look. Like this is my DynamoDB. This is my Autohome collection. This is the device database that store my devices. I have 3 lights and 3 thermostat. And here is the logs. That means that's my event database. So once we made a change, we can see if there is something change here. This is my Lambda. So Lambda taking a trigger with Kinesis string here. And once if there's input from Kinesis, we just split the message, doing some analysis, and then making some actions. And after all, updating this to databases, it will just update through my MQTT topic. It's called Autohome topic. So you can see the message in MQTT. If you go to AWS IoT, choose the device test here, MQTT test client. And here you see we have already subscribed to Autohome topic. So let's try to my client, see what we're having now. So Okay, so you see I have 3 lights and 3 thermostat. So this is your action you can do. You can add or remove a light, switch a light, set temperature, and see your device database or event database or exit. So let's try add a light. So we have 1, 2, 3. Let's try L4. So it says L4 is added. See if L4 is here. All right, see we have an L4 here. Yeah, see here. And now let's try to remove a light. So let's do 1. And let's remove a light. Try L4. Okay, it says L4 is now removed. See if L4 is there. Okay, now it's going to just 1, 2, 3. If we refresh here, there's no L4. Now let's try switch light. So see light L2 is on. Now let's try to switch it off. Okay, L2. Switch. Say L2 is turned off. Also L1 is false, so let's try L1 first. Let's see if L2 is false. All right, it's getting all turning off. So let's try to turn on 1 light. So still 2, and let's try 1. Okay, L1 is now true, so that means turning on. So here, see L1 is turning on, others are turning off. Okay, and now let's try set a temperature. So let's say we need to set T2 to 78. So now they say set thermostat T2 to 78 degrees Fahrenheit. So let's see if now 78. Okay, it's now 78. So if we take a look at here, 78, right? And also we can see my logs by C event database, so which is 5. So we can see here, this is what I did. So add L4, remove L4, turn off L2, turn on L1, and set T2 to 78 degrees Fahrenheit. We can also check from here. This is my event database. You can see all the things showing on here. Also, you can also take a look at this topic. You can see all the messages I've already delivered here. So once you have devices connect to this topic, you can just taking things message from here and then do some other actions based on these messages. So that's all of my demo. Hope you enjoyed it. If you have any questions, feel free to ask. So have fun. Thank you.